Hi, my name is Brina, and I'll be talking about simple and fractional distillation. So first of all, the reason of simple distillation is that we're trying to separate two or more compounds from each other. And basically the way we're doing it is like we're manipulating their boiling points. Alright, so in this experiment we were separating ethanol and water. Those are our two compounds. And what happens is that in simple distillation is that we boil our whole mixture. So ethanol has a boiling point of 78. It will evaporate first, and then once it touches the condenser, the condenser has a water running through it. It will feel, oh, this is a cold surface, so it will condensate back into a liquid phase. And this is basically what happens in simple distillation. It's just like it's evaporating and then it's condensating back. However, in fractional distillation, we have that one piece that we add to it, and this piece is called distillation column. So what happens is that in our distillation column, it has those little beads. So once we boil our mixture, our ethanol is gonna go and evaporate at 78. However, once it touches that bead, it's gonna condensate on that bead. And then from that bead, it's going to evaporate back again. And then once it touches another bead, it would recondensate back. And so on. So as it goes through, it's just going from evaporization to recondensation. And we simply use simple distillation when our differences in the boiling point is huge. Like for example, in this experiment, ethanol has a boiling point of 78 and water has a boiling point of 100, and like we can see that those boiling points, like there's not that huge of a gap between them. This is why simple distillation is not efficient in this experiment. However, fractional distillation, we can use it when our difference in the boiling point is pretty small, like here. So what basically happened in simple distillation is that we're boiling our mixture, right? So our ethanol is evaporating at 75. So at 75, it's going from its liquid phase to its gas phase. And then from the liquid phase, from the gas phase, it goes back to a liquid phase and it would condensate back. So when we're going through a phase changes, usually the temperature is constant, and this is why we see it's constant here. And then once we hit our 100, our water is gonna evaporate and condensate back again. And we can see the difference between the simple and a fractional, that at fractional, since we have a multiple vaporization and condensation, our line here is more constant. However, in simple, we kind of have this little slope. That means that ethanol is not completely purified. However, in fractional, since it's going through like a multiple vaporization and recondensation, that's why our ethanol is more pure. Alright, and since alcohol has a lower boiling point, it has a boiling point of 78, it will evaporate first and then it will condensate first. So at first we're distilling ethanol and then we're getting our water at 100 Celsius. And there is a limit to the purity, like how much the alcohol is purified, since even though like alcohol is evaporating at 78 Celsius, water is still evaporating along with it, and we can't do anything about it. And then here our hydrogen bond, water has a hydrogen bond, and since it has a hydrogen bond, it means like the hydrogen bond is pretty strong, so it needs a lot of intermolecular force in order to break the hydrogen bond. However, in ethanol, even though we still have a hydrogen bond, but it's not as strong as water, since we have this bulky big group that makes the hydrogen bond is not that strong, and this is why we can break the intermolecular bonds in ethanol easier than water. And then since the intermolecular bonds in ethanol are weaker, that means that its boiling point is lower than the boiling point of water. And in order for distillation to work, we must have two things. First of all, like our two compounds, they must have two different boiling points, because we're basically manipulating their boiling points and separating them out. And the other thing that like our compounds, they have to be soluble in each other. That way they would have different boiling points.